Afternoon, this is Mr. Schweitzer. Gonna do a quick little video here on how to run video analysis. Most of this is not really involving any physics, it's just physically how do you go about running this particular program. You should find on your desktop or at some point in the program computer, you would look at what's called your Logger Pro. And it opens up, I opened it and it looks just like this. At that point, we want to simply drop in our video. Now, our video could be located somewhere online. I have my video here, located right here, and this is my location. It's on my B drive. Where the video is located could be online, could be YouTube. Just depends on how I happen to have it set up, but you'll need to access the video. To do that, there's a couple ways you can do it. You can go to Insert Movie, and I'll just do that. So I'll go to this location of my particular videos here, and you will see this. Most likely to probably be on your most likely be on the desktop. So, and I'm looking for which one lands first. This is the video that I'm going to just kind of walk through how this works. You can watch the video and you'll see it just shows two particular balls. One is on a magnet dropping down and one's coming across, and they happen to at the same point in time. You can step through the video with these little toggle switches here. This goes to the front, so just toggle it through and you can see that this thing just slowly comes across and they both fall, and you can watch the video. We're going to analyze that video. Which one lands first? So essentially we want to know which one, does one fall faster than the other. So the computer, based on the number of frame rates and the relative positioning on the screen, it's going to tell us all about the movement of that object. Now they're both in the same plane. This is the X and this is the Y component. We're more concerned with the Y component, which is how fast it falls down. We could, however, look at the X component and see how fast it's moving in the X component as well, based on how fast it's moving here at this point. So either way, we're concerned with the Y. So the first thing we do is insert the video. This particular button here, and there's a bunch of them, play around if you want, but this kind of opens and removes this side panel. Okay. Few things we need to do for this is, one, we need to set and basically tell the computer where's the origin, and that would be the button I've hovered over now. It's called Set Origin. Now before I do that, I just want to get the video to a place where I want just to where I'm ready to go. Now right here, this is frame 4. I have both of these guys very close to being starting. One's going this way, one's going this way. I'm going to track this ball falling straight down first, and then the next one I'll track this guy. So by putting the marker over the top of that ball, it just says, okay, just so you know, computer, this is the starting point that we're starting from. This is where our measurements are going to start from. A few other things we want to do here is, one, we want this button here is called Set Scale. It tells the computer, okay, every screen's different, and every frame of reference is a little different. So, but on this screen, what's what? How far is an inch? What's the scale? So what I do is I click on this, and I'm going to go tell it from here to here is a specific distance. It should be able to, you gotta drop it, you gotta drag it. Okay, it's not exactly, it's close. Now on your work packet, you will find a list of just general reference points, and what falls first, it says magnet floor is 0.6 meters. So 0.60 meters. Now, because I'm on the same plane, it can tell, based on this being 0.6 meters, what everything else is. Alright, next thing here, we're looking at just setting our graph up, and this button here just simply says, okay, the first frame of the video, this would be the 0 frame here, but I want this to be the 0 frame, so I'm just going to and this out, put a 0 in here. The movie time is still 1.33, so the time of 1.133 matches with 0 on the actual graph. Okay, hit OK. All right, now the next thing here is just to simply mark out some points. This red button right here allows me to mark points out. Now I'm just going to basically every frame or every couple of frames right there, I hit the left button on the mouse, and it will mark a point. And you don't have to do every one. I could go like this and click forward one, which is fine. And some parts of the video might be easier to see than others. I can go ahead two or three. It doesn't really matter. But I'd like to get as many good points as I can. So I would have liked to have taken those last ones, but there we go. And finally, there we go. And if you see it hit the ground or hit something else, that you're done before that. You can't. Just looking for free movement here. Now I've marked out a bunch of points out. I'm actually on frame 14 now, so 14 of 14. That's the end, I guess. Here's my frames right here. Either way, now I'm going to analyze this thing, and from here I go to what's called curve fit. So we're only going to analyze the Y. We're looking for the gravitational pull down, up and down. We don't care about left to right movement, only up and down movement. And at this point, this curve is not a linear, it's speeding up. So y equals mx plus b. This would be a straight constant motion relationship. So we're looking for this one right here. And this is your, what looks like actually is like your distance formula. This c is your original, it's backwards obviously, but c is your original placement, initial velocity times time, and this is your kind of like your acceleration right here. A represents your acceleration of gravity. So A equals 0.5 of gravity, 1/2 times gravity. So either way, try it fit, and there it goes, fits nicely, and then hit OK. At this point, all I would ask you to do here is to create a little text box explaining each of these parts. In this case, I'll just show you here and insert a text. What do we got here? Insert text box right there. Okay, and I would just point out to you that in this case, the letter A, the big A, is equal to 0.5 of the acceleration of gravity. So in this case, the small a is equal to 2 times, we solve for a, the small a, 2 times the big A. And since the big A equals 4.19, then times 2, this is going to be, well, I'm going to go 4.2, so that would be equals then the actual A value times 2 equals negative 8 point, let's go 4. And notice that that is our gravity on Earth is negative 9.8, and again it's meters per second squared. And it's not exact. This is the point placement. It's just, it varies. So it's close. It's close. I'd like to be a little closer, obviously, but it's pretty close. B is your initial velocity. It's saying that there was a little bit of a kickoff. Maybe my origin was a little bit down. It was moving a little bit. I could have put it a little higher, where it was at 0. Again, there's a little error here. And C is its original placement, which is really close to 0. So both, technically, we'd like to see both B and C be as close to 0 as possible. Again, that mostly is based off slight distances on your first point. Right? So A is the acceleration, B is the initial velocity, and C is the initial placement. And you would want to have all that detail in a text box next to it. Now, if I want to do the next ball, okay, the only difference is that, again, you can watch it again, And I'm going to stop the video, okay? And I'm going to put toggle it forwards, okay, if it lets me. Okay. Okay, now, remember the same time, my origin has to be changed. So I'm going to set a new origin, and if it won't let you, in this case, it may or may not. Okay, there it goes. There's my new origin. Okay. At that point, your distance is the same. Okay. You can set if you want your scale should still be set at. Okay, you have to measure. The green line actually is the measured scale, so it's still there. That's your scale that we set last time. So I'm not going to change it. Again, we still have our starting point. Now, it's saying that our starting point now is a very 0.000033. So this is very close to 0. If you want to tack it to 0, you can. But I'm just going to use my point marker here to just simply mark out all my various points. And you will see, okay, and now in this case, it's putting my blue dots right here. Okay, so I'm just going to say if you have issues where it's not putting the marks right on your actual dot, simply close the video out and reload the video and run it fresh. Okay, run a fresh version of the video. That's what I would do at this point. I don't want my dots falling over here or my dots actually landing on the actual piece. So if you have a situation where it's not the dots, blue dots not landing on your actual item, let's see right there's one. Right, they should be landing right on the actual blue guy. So I, for some reason, had one there, but I want all of them on this location. In that case, just simply insert the video fresh, and I would have to surf to get that point, but insert it and rerun the process again. All right. You have a couple assignments to analyze a few other video points, different videos. Go ahead and give that a try. Thank you.